Welcome to the Autonomous Rover project. Let's begin. Rover is a skid steering mobile platform intended for autonomous driving research. At the start of the project, only the physical construction of Rover was completed. This has guided the goals for this project, which are create a ROS-based working environment for the system with teleoperation and a base set of sensors, analysis on the behavior of the base system in operation, update documentation, and develop a gazebo simulation and digital twin. Roster environment. The created roster environment is hosted on a JetSon, having direct drive and kinematic model-based operation with teleoperation. Installed sensors consist of BPL and RS16 LiDAR for SLAM and object detection, a Intel RealSense T265 for odometry and visual SLAM, along with implementation in simulation, is also installed. Visualization of sensors behavior. LiDAR's behavior have been examined in Gazebo simulation, which provides enhanced testing capability. Here is a dry showcase of point cloud of LiDARs in camera visualization. BPOL is mounted in a way to allow high resolution object detection and RS16 for better 360 vision. Gazebo simulation. During the project, a gazebo model with the identical interface to the real rover was developed. Gazebo-based simulation offered a risk-free environment for analyzing rover response in diverse conditions, which enables fast iteration and detailed analysis of ROS functionalities and integrated sensors. A digital twin was developed to provide a visual counterpart for testing and data. Testing data acquisition and analysis. The base system's driving characteristics were tested and measured in icy conditions. Here are real-time direct drive measurements for comparing input-output wheel RPMs in T265 and model odometry calculations. Conclusion. During the project, the outlining goals have been mostly achieved and well documented using version control. The robot platform is now equipped to be used in further autonomous research. Thank you!
Kiitos.
Shukriya.